Good morning, ETH Prague. Welcome to the Institute of Crypto Anarchy. I am Camille, and I love you. You are my family. Thank you for being here. Next up, we have Crossing the Interoperability Bridge, a deep dive into building interoperable dApps with IBC. Welcome, guys.
Thank you. Hey, guys. I'm Daniel. I'm a lead product at Evmos. I usually ask our team why we're doing things. And we're going to talk about building applications that are interoperable. Fede, do you want to give an intro to yourself?
Hi, everyone. I'm Federico. I'm the co-founder of Evmos. I've been in the Cosmos ecosystem since 2017, where I started first building the Cosmos SDK and later was part of the core team that shipped IBC. IBC is the inter-blockchain communication protocol that powers most of the interoperability in all the Cosmos ecosystem. And today we're going to be doing a deep dive into how Evmos leverage IBC in order to build smart contract interoperability. So after that tongue twist, crossing the interoperability bridge, we're going to do this deep dive into IBC and how Evmos comes into this game.
Also, maybe originally we had planned to do a workshop that's hands-on, but since it's the last day and probably everybody's already started hacking other projects, we have more like a presentation format, but we have a bunch of tutorials online. And we're also going to play a video in the end, but yeah.
Awesome. So today we're going to be talking about why there are so many chains, why are different chains specializing in different use cases, how do EVMs come into play, and how does this impact overall user experience. Then we're going to be talking about why interoperability is important, why is it necessary today more than ever to build interoperability standards to allow these smart contracts and applications to talk to each other. We're going to see the consequences of an ever-increasing number of chains, layer 2s included. And then we're going to do this deep dive into the IBC protocol, explaining how it works, and also talking about, of course, Evmos and how we take interoperability to the next frontier, and how do we enable smart contract interoperability through IBC to connect not only to smart contracts, but also to other chains in the Cosmos ecosystem and the EVM world.
Maybe a quick check-in. Who knows IBC? Has ever heard of it? Okay, that's quite some people. So you guys are familiar with the Cosmos ecosystem in general, more or less?
Somewhat.
Okay. Yeah, that's good. We'll talk about it more.
Okay, today, why are there so many chains? Nowadays, back in the 2015 era and 2017 era, where all these ICOs started booming, the only choices for developing a new platform or a new project were either forking Bitcoin in the early days, like, for example, Zcash, and on top of that, adding privacy on top, Litecoin, etc., until Ethereum came into this world. And through Ethereum, people now started building smart contract on top of the same platform, which was great. You can build different applications, different use cases just by writing your smart contracts, and this was like a shared stack. Until in 2017, Cosmos announced its vision for an interoperable world of smart contracts, where the premise here was there should be applications that are not only able to live on a shared virtual machine, but should also have full ownership and sovereignty over the entire stack. That means that using an SDK or a programming framework like the Cosmos SDK in this case, you will be able to write your own application-specific blockchains, or app chains as they're called, and interoperate with other applications through this interoperability protocol called IBC. So instead of going through a horizontal scaling, we shift the model to a vertical scaling, where you handle more TPS, you handle more validators or nodes that are participating in consensus. You're just scaling horizontally via an interoperability protocol. And this is key to understand that on Ethereum, we find all these smart contracts that are able to share code with each other. You're able to call other smart contracts and compose on top of each other. The money Legos, the DeFi Legos as we know them. But with interoperability, that's also a missing case. So once we started seeing an ever-increasing number of applications, layer 2s, specialized for different use cases, we're starting to have these user experience problems as we see here. So we have, like, for example, Aave or Curve that are now deploying to multiple environments, multiple EVM chains, and that also comes, that's also affecting the overall user experience.
I guess another check-in, like, do you guys actually use all of these chains when you're using Curve or Aave? Any opinions? Is this something that you're excited about, or do you actually care? Okay, no strong opinions. Okay, well, we believe. So you. Okay, so you said you care because there's different features or functionalities, and you mentioned liquidity. Is that the only thing? Because usually we talk about, like, the EVM compatibility between those chains, so that's easier to deploy the same application or same dApp on multiple chains. Is there anything else but liquidity? Okay, well, it's good to know, because our goal is to basically remove that selection for the end user. So overall, like, UX is becoming more and more important, and so we're pretty aware of that.
Yeah, so this is...
Wait, there's another one?
Does that mean at the end of the day, what chain you're on would be relatively transparent?
I mean, ideally, as a user, you just show your intent of what you want to do, or the program, and you're not really concerned with the network, but you have to have some entrance point, and then what happens on the background, depending on, like, which chain it is on, is really not of your concern, actually. That's why I say it's like the selection, the drop down shouldn't be there.
Nice, thanks.
I mean, what you see here is, in the Cosmos ecosystem, we have so many chains popping up because they're optimizing for one specific application, right? They're like application-specific blockchains that allow for, you know, sovereignty. They have their own token, their own validator set, their own community as well. They're, you know, you could see them as all individual DAOs, and that's actually really interesting. It's like the Cosmos ecosystem is trying to basically build this scalable way of new chains that are, you know, opting in to connections with other chains. But they could, you know, it has like very good security implications. You know, if one chain dies or something goes wrong, it actually doesn't really affecting other chains. And so in the Cosmos ecosystem, we're really trying to tackle the idea of scalability in a very different way. Whereas on Ethereum, it seems like everybody's kind of, you know, building on Ethereum until it becomes expensive, or it's not really scalable, and that's how we're coming basically from two different sides and trying to connect them.
Basically, the layer 2 vision for Ethereum is what Cosmos initially envisioned as, like, okay, you have application-specific blockchains that communicate with each other. Now you have layer 2s that are specializing in privacy. You have rollups that implement, like, optimistic rollups, CK rollups. And then maybe there might be some layer 2s that are only specializing in one specific category of applications, say DeFi or NFTs or refi, or DAO tooling. For example, Gnosis Chain is really big on DAO tooling and DAO frameworks. So there is going to be like a transition into like going to the niche of your users and targeting that niche and having interoperability come into play. And of course, there's like scalability concerns and of course, composability concerns, because now the Legos that were previously available to you on Ethereum, like all these smart contracts, amazing smart contracts that now are very expensive to run, are not available to you on your EVM. So how do you go about it? If you want to build like an amazing application that requires Chainlink, but Chainlink is not available on your EVM, now you can't build a lot of the DeFi primitives like lending markets. So how do you interact with other chains that do have these Oracle services in order to compose and build on top of that? And that's what Evmos is trying to do. So we saw that onboarding users is really hard. Users don't need these don't need to choose which platform they're in, what wallet they're signing. There are like different standards for signatures. So ideally, these should all be abstracted and basically, as Daniel mentioned, based on the intent, the application should be the one directing to the corresponding chain or to the corresponding smart contract on different EVMs.
So this is just an example, because like I mentioned, you can come into like the Cosmos ecosystem or Ethereum from like different angles, right? Either a friend tells you, sends you some ETH, or you're in some testnet, or you're a developer. Like there's just so many multiple angles and communities to tap into, and so onboarding users is really hard, depending on the previous knowledge that they have. And maybe also if they already own some crypto in a different ecosystem or just are trying to on-ramp from fiat. So that's a problem that we're really aware of in the Cosmos ecosystem. And we're trying to, we have I guess also our front end or our application where we want to unify this onboarding experience and help users. And we really understand that building like assistants or like co-pilots to like lead users through that experience is quite important. And the whole goal is basically we want people to onboard just once to crypto in general, or to to crypto in general, basically, instead of having to force people to download multiple wallets or have this notion of like 10 different accounts depending on which chain you're on.
So basically the premise is, okay, I want to onboard to Evmos. I want to use a smart contract application on Evmos. I have tokens somewhere else. How does the front end know where those tokens are located and through which route to route them through Evmos in order to start using that decentralized application? Then once those tokens are in Evmos, what happens with the Evmos tokens that you need to pay for transaction fees? So that's another limitation. So like in the user journey towards onboarding specifically from other chains, you need to take into account like different routing mechanisms, different costs associated for the transaction fees. First, in the Ethereum world, like for example, if you're bridging directly from Ethereum. But then there's the other concern that maybe Evmos is not your last stop. Maybe it's like you're routing tokens through Evmos to the rest of like Cosmos ecosystem chains. So what happens afterwards? Do you need to send another transaction, like bridge to Evmos, then another transaction to somewhere else? That's a painful user experience, and that's why we're trying to work with these core technologies around interoperability that are going to be 100x the overall user experience, not only for us, but in general for the entire ecosystem. And our hope is that in 2 to 5 years, Like everyone will start using these smart abstractions for transaction fees, for routing through the ecosystem based on the shortest path or on the cheapest path to like a destination on another counterparty chain. So this is our first attempt to also improve the discoverability. So before you onboard, you need to have an intent. Okay, what am I going to do on Evmos right now? And for that, discovering what the possibilities are is really important. And on Evmos, we're trying to push for our dApp store, which is showcasing in the same way that you might experience with your Google Play or App Store on your phone, showcase the different developers, the latest news, leaderboards in different categories for DeFi, gas guzzlers, what are the most used or more popular smart contracts being interacted with. We're also showcasing different content that is going to be, and announcements that are going to be created by these different teams. And this is like our first push to like declare first the intent, and then through the onboarding experience that we just mentioned, attract more users to the Evmos ecosystem.
Yeah, I think the idea of this also is, if ecosystem dApps that you see listed here shouldn't be just deployed on the Evmos chain. You could also think like this is the Ethereum dApp store or whatever. But the point is, you don't really know where these applications are actually hosting their code.
The second big topic that we're working on, besides onboarding new users into our ecosystem, is changing the mindset from going multi-chain, like deploying different instances in different EVM chains, to just being cross-chain, deploying once and having these interoperability abstractions to work everything for you and not having to suffer this user experience of like going through the drop-down and interacting with multiple blockchains that might be hurtful for overall user experience. So this is how it looks like today. We took the example of Aave. So today you can interact with Aave on different EVMs, different layer 2s, mainnet on Ethereum, etc. But Aave not only has one single version deployed, it has like multiple versions. And what was being described here before is like, okay, you have like access to different functionalities, but what happens with the engineering team that needs to maintain and keep track of all these new functionalities? They need to have like separate instances with that specific functionality on different chains. And moreover, not only for the engineering team that needs to maintain more instances and keep track of like any breaking changes, any upgrades specifically on EVM chains that are not using Nakamoto consensus but are using like BFT consensus, they need to keep track of that. And also for the community teams, okay, what's going on in terms of governance, how our community, like our Aave community, is getting involved in all these different instances on all these different chains. Am I participating in governance? Are they able to participate in governance? You have Snapshot that is deployed on Ethereum, like for voting. How do you manage Snapshot across different instances as well? Do you need to submit a different integration for every single EVM chain? So like those are the questions that today a developer needs to ask themselves if they want to go with a multi-chain strategy. But the ideal case scenario, and we're talking about 5 years again from now, is like you only have one instance that your team needs to deploy, and you can access it from every single EVM chain, every single Cosmos chain, every single smart contract, not only Solidity or like EVM-based smart contracts, but also WASM smart contracts, JavaScript smart contracts, Solana smart contracts, and you can, through the interoperability, compose and build on top of it. So this is a vision, the longer-term vision that we're trying to aim for is like deploy once, connect with everything. And this is why it's so game-changing, and why it's so important, the interoperability, that besides all the user experience, it also brings huge benefits for the entire development teams. And the entire, like, you don't need to hire like 5 community managers, 1 for each ecosystem.
Sounds good. So the idea is when you just deploy once, right? Or when you are trying to, actually when you're trying to create a new application and trying to build a new application, currently in the Cosmos ecosystem, one way is to do it, you just launch your own chain, have some like custom core protocol functionality. Maybe your application is baked into the protocol, or you're running a VM and building smart contracts. But the idea is it comes with a bunch of problems, right? So Fede was mentioning earlier, you actually, every time you build a new chain, you'd have to rebuild certain basic applications to have a rich DeFi ecosystem or any other. Just DeFi is the most prominent.
The primitives.
The primitives, the building blocks. And so if you have this notion of being able to access data or I guess liquidity on other chains, you don't really have to think about and worry about bootstrapping these basic building blocks. So basically we're rethinking the way that we also measure, I guess, the success or the activity on a chain. A lot of chains are thinking about, okay, how do we optimize TVL, or just use that as the main measurement of success and maybe also possible revenue methods. But for us, it's actually rethinking this, and we want to make sure that people just think about access, right? You don't need to build a protocol like always launch your own token and then optimize for TVL. It's rather, how do you reuse components or liquidity that other teams already have built up, basically. So it's kind of like, if you think about it, like every chain could be like a different API or different service that you can have access to. And I think the UX point, I mean, we mentioned it quite often already. One big idea is that you don't need to be concerned with like paying transaction fees in different tokens. You can just onboard once to your one favorite token, maybe Evmos, ETH, whatever. But you just connect it once, and then you're paying transaction fees for services, even if they're on other chains, with that token. And that provides just a better user experience.
Yeah. The access to liquidity part that Daniel just mentioned is very important. Right now, everyone knows that you don't have wrapped first, you don't just have Ethereum, you have wrapped ETH, staked ETH, and different denominations of liquid staking Ethereum. So in that sense, the original token, the ETH token, is now fragmented across different denominations only on Ethereum. But what happens then when you bridge them over somewhere else? And then like it fragments the single token even more. So like, now you have like this initial pool of tokens, the ETH token, that is scattered around different denominations everywhere in the ecosystem. So how do you access that liquidity? You can't just build pools that have like the initial value of the tokens, but you need to work with what you have on your local chain. So, and that's the concept of total value locked, the TVL, that a lot of chains are trying to optimize for. And our shift of paradigm at Evmos is not how can you build more TVL natively on the chain, but how can you access that liquidity that is scattered everywhere? So how do you enable a smart contract that lives on a chain that doesn't have like these DeFi Legos that I mentioned that you need in order to build your smart contract, and doesn't have deep liquidity for your application to exist? And this shift of paradigm allows us to rethink how these smart contracts should be interacting not only with other smart contracts in other chains, but with application-specific blockchains like Osmosis, which is the main DEX app chain in the Cosmos ecosystem, to access that liquidity via interoperability, getting those tokens back, and then using them for whatever use case they might need. So access to interoperability is a keyword, not total value locked on a single chain. Let's expand from the constraints of the single like EVM and look beyond that into what's over there scattered and fragmented in the rest of the ecosystem. And so that brings us to our next topic, which is the inter-blockchain communication protocol that I was glad to be part and build with the rest of the Interchain team. So the inter-blockchain communication protocol, I'm going to go explain what it is. But basically, you have, in this case, two chains with their own validator sets, around 100, 150, 200, 300 validators, coming to consensus and validating blocks. So the main thing is like, okay, Bitcoin solves the double spending problems. Right now, when you're thinking about cross-chain, how do you solve the double spending problem, but when you transfer over to another chain? So how do you prevent this issue? And for that, you need to be able to validate the state transitions or the transactions, moreover, on one chain, on another chain. And for this, is critical the role of the light clients. So light client proves there's an actor in between that I'm going to explain right now that runs light clients of both chains and is able to verify the state transitions on chain A and chain B and constantly update the latest state. Updating, for example, updating the state of the chain A for chain B and vice versa. And with that, you're able to verify that a token has been locked, a token has been released, a token has been minted, or a token has been burned. So how does IBC work? The concept of IBC first was meant to be defined in the same way as the internet protocols with different layers. So you have the proofs that are like Merkle proofs to be able to verify the state transition. That's called ICS 23 here. Then on top of that, you have the light clients. The light clients are, as I mentioned, the key components to be able to verify state transitions between the different chains. So there's one relayer here in the middle. I'm not sure if this is here. Here, the relayer in between is able to run the light clients for both chains. So this is like the bottom layer clients, IBC clients, and the light clients for the different chains. And on top of that, you have the connection. So connecting one chain to another is the next primitive. And then on top of that, you have channels. So what am I connecting right now? You had the connection between one chain and another, and then I'm connecting, for example, the transfer logic, like the state transition for balances. So that would be, for example, okay, I want to transfer some tokens from my chain, chain A, to chain B, or Evmos to osmosis. I'm updating my balance on Evmos, reducing it. I'm putting it on an escrow. That Merkle proof is submitted via the relayer. The balance is updated on the chain, on osmosis, on the receiving chain. You get an acknowledgement back that the transaction was successful, and then that token that was held in escrow is then burned. And that's how it finalizes the state transition. And
I guess for the channels, I think like right now, basically you set up a channel for different packet types, right? And the one that's mostly used is the transfer. But actually, IBC is data agnostic, right? So you could send any kind of data that's encoded. I just wanted to mention that still.
Yeah, and on top of that, you have the application layer. So after you set up you have the proofs, light clients, connections between two different chains, channels between two different smart contracts or modules in the Cosmos world that are able to decode and encode data, the packet data that is sent over in this envelope, this packet. And then you have the application that handles that specific data that has been decoded once it's received. So that's how the IBC stack works. So it's not very clear here, but like the cross-chain user experience, you have like two models for cross-chain user experience. One is using an application, an IBC application that is using a specific channel. So for example, I want to send tokens from my chain to Evmos to Osmosis, and what I do use is here's the interchain agent, talks to the IBC transfer module with an IBC transaction that declares an instruction to transfer. But what happens with, and that works for transfers, like bank balances that need to be updated. But what happens with other transaction types, like staking, if you want to vote on governance for another chain, or if you want to, what's this? I don't see it.
CTP?
CTP. So like other whatever modules you might want to build. And for that, cross-chain user experience, going back to the same problem, like how do we remove this need of having to switch different networks, is just having one single account on Evmos that now through smart contracts or on your behalf is able to send instructions everywhere to submit different transactions. So you remove this drop-down completely and just use Evmos, and you're able to send instructions for all the different chains that you have tokens around, for all your portfolio tokens. And then you are able to send IBC transactions, for example, the transfers, and non-IBC transactions that are like local to that specific chain. For example, staking or sending a governance vote or sending a CDP action. So those are the two different UX models that we have right now. One is like just using an IBC application, which is perfect specifically for the use cases of like just using it once. But if you want to manage something on the medium term, you can use interchain accounts, which will allow you to manage your portfolio without having to leave the receiving chain. So going back again, transfers, I wanted to send a transfer over, transfer to the receiving chain on, for example, Osmosis, Evmos, Osmosis. The balance is updated here. You send a receive here, and you can have that token sent back to you, or it can be kept here. So one single action. And let me finish this, and I'll give you the word. And for more management, or like management over your portfolio, you can just like send the instruction to the receiving chain for all these different interactions.
The zone, that's like a standalone blockchain, right?
Yeah.
And the interchain agent, is it a part of the full node implementation of that original blockchain? Or is it like standalone?
So the interchain agent here, it was defined as such because it's either a user, like an EOA account, externally owned account, like a user, or a smart contract. So imagine this is a user, just like a person here interacting with the IBC module on Zone A, but it can also be a smart contract and a user here interacting with that smart contract or series of smart contracts that are using the IBC module, transferring to the corresponding chain.
And the IBC module has to be implemented in my full node?
It's already implemented on Cosmos. But
So just so it's on record, he was asking if IBC has to be implemented on the zone, right? Is that the question?
Well, the question is, where does the implementation go into? Like, do I have to include the module into my full node
Okay.
or do I run something that node?
Yeah. So you're asking where does IBC where is it implemented? So every zone on Cosmos can decide to just inherit the IBC logic. But it's part of the node, basically, like the full node.
And we're going to talk a bit later, how can you leverage IBC being a smart contract Solidity developer? So you don't have to implement all this logic. This is already abstracted for this, and you just use Solidity interface with the AVIs. So Evmos, working on these three main items, is taking interoperability to the next frontier, working on these like different use cases, particularly around onboarding, UX, and access to liquidity. We're going to be talking a little bit about that now.
So we mentioned Evmos quite a lot. For those who don't know, we originally created Ethermint, which is an EVM library, which has been used by not just ourselves, but also other chains to actually launch their EVM chain, especially in the Cosmos ecosystem. And we only see actually more and more EVM chains emerging. So that's kind of our thesis, why this interoperability is super important, and also setting the standards of how these chains will be able to interact with each other. And it's really interesting to be here at ETH conferences. And last week we went to Gateway to see how also different the communities are. So for us, it's quite nice to bring these worlds together. And we chose to, build the EVM implementation, or use, I guess, an EVM implementation in the Cosmos ecosystem to combine both of the best parts of those two worlds. So composability through smart contracts from the EVM, but then things like sovereignty, or the whole scalability of the Internet of blockchains in the Cosmos ecosystem. Okay, it's a bit hard to see, but basically the EVM extensions are the functionality that we're building to allow for interoperability from the EVM. And without these EVM extensions, you have maybe your smart contracts deployed on the EVM, but they're pretty isolated. You don't really have access to data outside or liquidity outside of the EVM. Smart contracts, as Fede mentioned, can talk to other smart contracts or EUAs to those. But they're pretty contained in the EVM. And the EVM extensions are basically the gateway for smart contracts to access core protocol functionality, such as staking, voting, or IBC. And so this means you can tap into, like, for example, if you want to build like a staking index through smart contracts that, as a user or a smart contract, you could automatically like stake or delegate your tokens with like a subset of validators instead of having to choose. You could build SAP DAOs with voting and governance functionality. It's actually like a lot of different possibilities. But I guess for this talk, the more important one is really the access to IBC, right? So you can have your smart contracts deployed on the EVM, but then send data to smart contracts on other chains, or basically create your own packets and define what kind of data you actually want to send. Right. So the EVM extensions are something that we already you can already use on testnet. We're running through some audits and then going to mainnet. But one of the first things that we actually want to enable are these things called outposts. So outposts basically, imagine you're on Evmos and you have another chain like Osmosis. Osmosis has the most primary DEX in the Cosmos ecosystem, and an outpost, you could build a Osmosis outpost on the Evmos chain. So this is basically a smart contract that users or other smart contracts can interact with to use the DEX, to use Osmosis. So it's done through IBC middlewares. If we go, think back of the slide we had, where you do the cross-chain transfer over IBC, somehow it has to be understood, right? And these middlewares basically take the packet and just forward it to the smart contract or the place in the VM that actually gonna execute the logic. Let's run through some, two examples. So we have Stride and Osmosis. Stride is really cool. They do liquid staking as a zone. So you could liquid stake your your Evmos, but also Atom or any other token in the Cosmos ecosystem. And they have a really great user experience, so if you haven't used it, go for it. And what you do right now is you actually have to send your Evmos token with one transaction to the Stride chain. Then you do another transaction to Liquid Stake, and then basically send the Liquid Stake tokens back to Evmos. And they already optimized this to almost basically one transaction for end users. But with an outpost, you could do this in one transaction from the Evmos chain, being connected to the Evmos network. It's pretty subtle, but basically what we did here is usually you're connected to, with your Stride address, but the big change is you're just connected to the Evmos network, and you can pay, like I said, transaction fees with the Evmos tokens, and then just sign one transaction and get back your Liquid Stake token on the Evmos chain. And that's just from an end user's perspective. But you could also write smart contracts that get the Liquid Stake token and then use it otherwise. Maybe deposit it in Forge. It's like a Uniswap v3 fork. Or do anything else for getting more yield. So this is how it kind of would look like. So basically, you're connected to, like I said, or just showed, to Stride. Or you're opening the Stride interface, but you're connected to the Evmos network with any of the wallets, Kepler, MetaMask, or Ledger. You send an EVM transaction that talks to the Stride Outpost contract, which then talks to the EVM extension, and then it will perform an IBC transfer with the asset, with Evmos in this case, to send over. And then Stride, just like an API, would execute the liquid staking logic and send back the liquid stake token.
What it's important here is that after you send the first transaction, usually you receive an acknowledgement back. So if your transaction was successful or not. So that's what smart contracts use in order to verify that the transaction that can use in order to have some conditional logic. If the acknowledgement was successful, then execute the next logic or the next steps. But the acknowledgement itself doesn't get the tokens back. It's actually another, as part of this first transaction that we went through here, you get the acknowledgement back, but the tokens is actually like another transfer of those liquid stake Evmos back to Evmos. But then what happens with the smart contracts that needs to handle those? And that is handled by the IBC callbacks that I mentioned before. So it's pretty complex from a technical implementation point of view, but we've abstracted all this user experience of 3 transactions into a single one, and not only allowing end users to interact with an interface on another chain, but also allowing smart contracts to compose and build with a liquid staking application. So basically, these DeFi Legos that I was mentioning before are now accessible through this outpost model that allows you to compose with not only smart contracts, but with external chains.
Yeah, maybe we don't have to go through it too much, but this is pretty similar. So you would be having an osmosis outpost on Evmos. So as a user, you onboard to Evmos, and then you can use a DEX to swap tokens, for example. So you're not connected to Osmo, but with your Evmos address. And going to the next slide, pretty similar. You'd have an osmosis outpost smart contract that you can interact with. We use the standard ICS-20 packet, which also has a memo field. That's kind of like a hack that is being widely used to basically send the right information to handle the call on the middleware. And so you'd send an Evmos token with your intent that you want to have Atom, for example, swap it on the DEX, and then send that back to the original chain.
So we talk about how to compose with app chains in the rest of the Cosmos ecosystem. But one key part is smart contract. So what happens when your smart contracts now wants to build and compose with other smart contracts on the interchain ecosystem? And that has always been a major limitation of IBC because it allows for these simple applications right now of just sending tokens. But we want to take it to the next level and be able to compose with smart contracts, not only in Solidity, but also in other VM frameworks like Cosmos WASM, which is a WASM implementation of Cosmos, Solana, Polkadot, etc. So how do we enable that? And the solution is called Dynamic IBC, which allows us to abstract the components of IBC into so that smart contracts can interact with one another through this dIBC interface. So I was explaining before that one of the main things that in the IBC protocol is a packet. So we have the light clients, we have the connection between two chains, and then we have the channels. And the channels is what allow one specific part of the state on one chain to talk to a specific part of the state in the receiving chain. And this state can be either a module or a smart contract. And the packets is what it's forwarded between these different channels. And you can see here that it has a sequence, what's the source, what's the destination, but more importantly, and then you have like some time data, but the most important part is here, the data. What's the call data? And with this data, you're able to call other smart contracts, get the acknowledgement back, and compose. So this is how we are allowing smart contracts to talk to one another by defining this call data and be able to compose not only with output with other chains via the outpost, but also with smart contracts that live elsewhere.
I think before we get into the demo, one important part is also, it's called dynamic IBC because right now we have certain packet standards like ICS-20 for normal transfers or for like interchain accounts. And it requires a chain upgrade for each chain to kind of, bake that interface into the core protocol. But dynamic IBC, as Fede mentioned, just has a data field. It's pretty arbitrary. And smart contracts now have the ability to define their own packets. So it doesn't really require any chain upgrades for new applications, more new interoperable applications to actually deploy and build their own logic, their own packet types that they encode on one side and then decode on the arriving chain. So I think that's the big game changer.
And now we're going to run a demo for how to use these IBC token standard for transferring tokens using a smart contract.
Yeah, so we just recorded this sending some Evmos tokens to Osmosis. So this is still just in a local setup, but it's also possible in testnet. You have an Evmos Osmosis chain, and it's connected through a relayer, as Fede mentioned before. You can query the balance of an account on Osmosis that we want to send some tokens to. It's 0 because we're just starting out. And this shows basically a smart contract that interacts with the precompile or the EVM extension. You see the packet. In this case, it also has a memo. This is the ICS-20 transfer, like the normal packet type. In this case, we also included approval. It's not necessarily, but if you want to have like proxy contracts, then you want to probably have an approval case. And so we have 109 test Evmos, and now we want to do actually a transfer to that address on Osmosis. Just confirm it, sign the transaction, wait for the block to be built, and the relayer to pick up the transaction and send it to the new chain. You see the first balance actually is still 0 because the packet hasn't been relayed, but then you see it actually arrives. And just for confirmation on the original chain or the address, the amount also has decreased. Pretty simple demo, but it's just an example on what you can do. And also, if you want to build, like I said, on testnet, this is already available. And yeah, that's kind of it.
Yeah, this is the most simple demo that we could have built, but usually after that, you want to check, for example, you receive the tokens. If, for example, you're using the osmosis outpost or the stride outpost, you get the liquid staking tokens, or you swap, you send some instructions to swap on osmosis. You want to check if the token has been received, and then like write down some conditional logic. Same applies, for example, for staking. You stake some tokens, you can rebalance those tokens, you can check every day whether or not your position is actively managed, if your validator is like jailed or has some downtime, and you can update this using smart contracts with our EVM extensions.
Also, we didn't really mention, I just mentioned it in the side sentence, but it's using precompiles. So who's like using precompiles on Ethereum? Probably nobody.
There's only
maybe
there's only a limited set of precompiles on Ethereum, but on other EVM chains there's like a few more.
It's not as maintained as other code, I guess, on each client, but for us it actually is a game changer, right? We're using precompiles to just understand at a predefined address, is there a call coming in, and then redirecting it to the core protocol, like I said, staking, whatever, IBC. And so it's kind of nice to see that this part of code is also now being able to like come to fruition in a in a very nice way. Yeah, come talk to us if you want to build with us, build applications. We have a testnet faucet. There's also mainnet faucet actually. We have a bunch of tooling. We have oracles, price feeds. We have block explorers for EVM, Cosmos transactions. Indexers, subgraph, like basically everything you need to build. Try it out. Talk to us afterwards. That's it. Is there any questions? Go for it. Maybe hand the microphone.
I had a question about the outpost. So we saw, for example, the stride outpost on Evmos. I was just thinking, who's the initiator? Like, who has to deploy and maintain the outpost? Would it be the stride team, the Evmos team, or could it also be like an application developer who does it?
Technically, you could have several outposts, right? Like anybody, it's composable. Like anybody, or permissionless, anybody could do this. But you know, ideally, probably we're going to be the ones doing it first, or the stride team. There is one caveat. So on Evmos, you can actually gain revenue from like the transaction fees. So you can register your smart contract, and anytime somebody interacts with the contract, you can get some of the transaction fees as the contract deployer. So there's an incentive to do that. You know, maybe you have the best interface. Maybe you don't even use the stride interface, but build your own widget that's like pluggable into somewhere else. Or you're just a more well-known team or whatever. It also ties in with the dApp store idea that we had. So there's a bunch of ideas of, you know, showing like verified addresses or presenting your application, and this could be an outpost as well, right? So there's, you know, we're definitely going to implement or kickstart it, but hopefully there's other implementations.
Yeah, for the go-to-market, I think it's important for us to showcase what's possible, and then having other teams come in, build their own outpost on Evmos. And yeah, hopefully we'll have like a single outpost for every single chain in the Cosmos ecosystem, and you will be able to interact them natively via smart contracts.
If you want to build it, we should talk. Any other questions?
Hey, thanks. The talk was great, by the way. So I was wondering, because you mentioned about the Cosmos ecosystem, but originally you were sort of talking about other EVM chains. So is that the same case, or are there any sort of additional steps? And one more question. What's your sort of timeline for mainnet?
So, I mean, the first step is that we're looking at what are the bridging or the bridging protocols that work, and IBC has just been proven in the last 2 years to be very lightweight and resilient. So there's also some work being done, like of other teams connecting.
Yeah, like Polymer.
Right, connecting more chains, or even having like a Ethereum-like client to connect over IBC. So we hope that goes in that direction, and we wouldn't really have to change much. But yeah, Polymer is actually also building exactly that. But yeah, there's a bunch of ideas of our teams that are working on how do you translate between IBC and another protocol. But yeah, that's kind of, I hope that answers the question. So yeah, I mean, the ideal case is that we connect Evmos and Ethereum, right? I think there's still a lot of work to be done for that, but that would be the ideal case. And mainnet for this, I mean, we're deploying to, like, we do another release candidate next week to make the IBC part possible. The staking and distribution is already available. Mainnet, yeah, a bit hard to tell, but hopefully, like,
Yeah,
in
we're
a month.
finishing some audits right now.
Yeah. But the idea is, I mean, we've had the precompiles or extensions on testnet for a while for, to enable to break it, have people use it, give us feedback on the interfaces that we've built, and the authorization logic, things like this. So just want to, we've done so many upgrades already on Evmos, so this is not a problem, but we want to make sure that it has actually a good developer user experience.
Thank you, Daniel and Federico, for that amazing talk on interoperability and blockchain agnostia.
Thanks, guys.